Okay, this is question number 6 from the paper review for Canvas test number 3. The question reads, two sides and angles are given. Determine whether the given information results in one triangle, two triangle, or no triangles at all. Solve the triangle that results. So the first I'm going to do with the information that was given is I'm going to go ahead and draw a triangle. I'm going to call this angle A, angle B, angle C. The side across from angle A is side A, the side across from angle B is side B, and the side across from angle C is side C. Now I know that was given, B equals 6, C equals 9, and angle B is 75 degrees. So when I look at this, what is given is side, side, angle. Therefore, this is the ambiguous case, which means I don't know if I have one triangle, two triangles, or no triangle. And I'm going to solve this using the law of sines. As I mentioned in the last video, if you saw it, you can use the height to determine if it's one triangle or no triangle or two triangles, but I prefer to do this. So the law of sines states that sine of angle B over B equals sine of angle A over A equals sine of angle C over C. Okay, so what I'm going to do, because of what I was given, I'm definitely going to use sine of B over B because I have angle B, I have side B. What I also have is side C, so I'm going to go after angle C. To get angle C, I'm going to use sine of angle B over B equals sine of angle C over C. So sine of angle B is 75 degrees over side B, which is 6. Sine of angle C, I don't know what angle C is, but I do know side C, which is 9. So 9 times sine of 75 degrees equals 6 times sine of C. 9 times sine of 75 degrees divided by 6 equals sine of angle C. Therefore, angle C equals the inverse sine of 9 times sine of 75 degrees over 6. So let's go ahead and plug that in the calculator and see how that turns out. So inverse sine of parentheses 9 times sine of 75 degrees end parentheses, and I'm going to divide that by 6. And when I do that, I get a domain error. And the reason why I get a domain error is, remember that sine, inverse sine, goes from negative pi over 2 to pi over 2, right? And I can only plug in values for inverse sine that the domain is negative 1 to 1. 9 sine of 75 degrees divided by 6 is greater than 1. So that's why it's resulting in a domain error. So what does this mean? This means that I have no triangle. And that's it. So that's all I have to do for question number 6. Question number 7 has the same direction. So let me go ahead and write down what we know. So question 7 says that A equals 7, B equals 5, and angle B equals 20 degrees. Again, the directions say two sides and an angle are given. Determine whether the given information results in one triangle, two triangles, or no triangle. Okay, so again, the first thing I'm going to do is just draw this out so I can see everything. Again, my triangles are not to scale. I'm just doing this to visualize what's going on. Okay, so angle B is 20 degrees, so let me plug that in. Side B is 5, and then side A is given as 7. All right, I'm going to use the law of sines to solve this because the case is side-side angle. Again, it's ambiguous, meaning I don't know if I have one triangle, two triangles, or no triangle. And I'm going to use the law of sines to see that, what's going on with it. When I use the law of sines, I see that I have angle B and side B, and I have side A. So I'm going to go after angle A first. So I'm going to set up sine B over B equals sine of angle A over A. So sine of 20 degrees, which is angle B, over side B, which is 5, equals sine of angle A, which I don't know, over side A, which is 7. So 7 times sine of 20 degrees equals 5 times sine of A. 7 sine of 20 degrees divided by 5 equals sine of angle A. To get angle A by itself, I have to take inverse sine of both sides. So inverse sine of 7 times sine of 20 degrees over 5 equals A. All right, so again, let's plug this in the calculator. Inverse sine in parentheses 7 times sine of 20 degrees, end parentheses, and then I'm going to divide that by 5 and then end the major parentheses. And when I do that, I get A equals 28.6. So I have angle A. All right. Now, I know I have at least one triangle. Do I have two triangles? I don't know. So I'm going to explore to see if I have two triangles. And to do that, I take and I find angle A prime. To find that, I take 180 less what angle A is. Because again, I don't know if that angle A pushes in and out. It's possible. So I take 180 less angle A, which I just found to be 28.6 degrees. So let's do that. 180 minus 28.6. And I get 151.4 degrees for alternate angle A. Now, I have to check, does that work? Okay, in order to do that, I'm going to add A prime plus angle B. Okay, so 151.4 plus given angle B, which was 20, that results in 171.4, which is less than 180 degrees. That means it's a viable angle. Okay, if it exceeds 180, then I know the angle doesn't work. So at this point, I know I have two triangles. So that means I have to solve for both. So what I'm going to do is I'm going to solve the first time around using angle A. Remember, angle A is 28.6 degrees. Okay, so if you want to, you could redraw everything out just to have clarity. So my first triangle, remember B is 20 degrees. A, I just found to be 28.6 degrees. Angle C, I don't know yet. I do know that side A is 7. And side B, we also knew, and that was 5. Okay, so basically, I just need to find side C and angle C. I'm going to go after regular angle C first. To find that, I have to take 180 minus angle A minus angle B. So 180 minus angle A, which was 28.6, minus angle B, which is 20 degrees, will give me angle C. And angle C will be 131.4 degrees. Okay, so now I have angle C. Now I have to go after side C. I have to use law of sines, so I'm using sine B over B because that was what was originally given, over sine of angle C, which I just found, over side C. So sine of 20 degrees, that's angle B, over side B, which is 5, equals sine of angle C, which I just found to be 131.4, over side C, which I'm looking for. Okay, so I get C times sine of 20 degrees equals 5 times sine of 131.4. C equals 5 times sine of 131.4 degrees all over sine of 20 degrees. So let's go ahead and figure this out. Again, use parentheses in that numerator. So parentheses 5 times sine of 131.4 divided by sine of 20 degrees. And when I do that, I get C equals 10 point. Actually, it's going to bring it up to 11 when you round it. So I'm just going to go ahead and make this side C equal 11. Okay, so I did regular A, B, and C, but remember I have two triangles. So here comes the second triangle. So if I draw everything out, I'm going to start with what was given initially. So again, this is not to scale. So remember, we have A prime and C prime, right? So B was 20, side B was 5, and A was 7. Now I have to find C prime, side C prime, and I have to also find angle C prime and A prime. Now I did find angle C prime, or no, sorry, I found angle A prime, which was up here, and it equals 151.4. Okay, so A prime is 151.4. So I have to find C prime. So let's go ahead and find angle C prime. Okay, to find that, I'm going to take 180 minus angle A prime and minus B. Okay, so 180 minus A prime, which is 151.4, minus 20 will give me whatever angle C is. So 180 minus 151.4 minus 20 equals 8.6 degrees. Okay, now I have to find side C prime. So I'm going to use sine of B over B equals sine of angle C prime over side C prime. So sine of 20 degrees over side B, which is 5, equals sine of angle C prime, which we just found to be 8.6 over side C prime. So C prime times sine of 20 degrees equals 5 times sine of 8.6 degrees. C prime therefore is equal to 5 times sine of 8.6 degrees all over sine of 20 degrees. And that sign looks crazy. I'm going to erase that and redraw that again. Okay, so in your calculator, use parentheses for the numerator. 5 times sine of 8.6 divided by sine of 20 degrees. And when I plug that in, I get C prime equals 2.2. Okay. All right, so I'm done with those two questions. Thanks for watching. I will pick up with the next question on the review sheet with the next video, which is going to be question number 8. All right, thanks for watching.